So rational expressions, or algebraic fractions, behave just the same way that fractions do in arithmetic. If you want to multiply two fractions, you can just take their numerators and multiply straight across, and their denominators and multiply straight across. And you are done if there is no reducing to be done. The problem that I set up here had all prime numbers, a 2, a 3, a 5, and a 7. So I didn't have any reducing that could be done. I'll show you where this would be some reducing in the next problem. If I want to divide two fractions, what I need to do is I need to multiply the first fraction by the reciprocal of the second fraction. Multiply the first fraction by the reciprocal of the second fraction. Some people say skip this one, flip this one, and change to multiplication. So that's what I've got here. Yes, you could go straight across and get 42 over 35, but then you've got to recognize that 42 has a factor of 7 in it. So a way to write that is 42 is 6 times 7, and 35 is 5 times 7. So those have a common factor of 7 that can be reduced, giving us 6/5. Well, I prefer to cross off a common factor of 7 here right away, and 14 divided by 7 is 2, and then I can go right to 3 times 2 is 6, and 1 times 5 is 5. So I can go right to this by removing the common factor of 7 immediately. So we're going to multiply and divide algebraic fractions in this section, and lo and behold, the first step again is factor everything first when it's factorable, and then remove common factors. They're equal to 1. For every 1 in the top of the numerator, there must be 1 on the bottom, or the denominator. But for division, we will invert the second fraction and then follow the rules for multiplication. Now, just to make it easy on you initially here, I'm going to go ahead and break these up into primes. So I'm going to call 15 3 times 5, and then I have times r. And 40 is 4 times 10, and 4 is 2 times 2, and 10 is 2 times 5. So really, the number 40 is 2 times 2 times 2 times 5. This is the long way to go about reducing. The number 20 is 2 times 10, but 10 is 2 times 5. So this is the number 20. Next to it is a 45, which is 5 times 9. But 9 is 3 times 3, and then it had an r with it. So this is kind of an exaggerative way to see that I can remove the common factors of r. I could have done it here just as well. I've got to be careful here. I got to catch everything. So let's see. Let's go with this 5 and that 5. One on top, one on the bottom. Let's go with this 5 and that 5. One on the top, one on the bottom. Let's go with this 3 and that 3. One on the top, one on the bottom. This does make this problem much simpler to do. I'm going to grab some more colors here. They're going to be very helpful for us. Let's grab a yellow. So I'm also going to remove a 2 on the top and a 2 on the bottom, and another 2 on the top and another 2 on the bottom. And let's see, what do I have left? R's are gone. I have just that 2 in the numerator. All these are crossed off, and just the 3. All of that reduced to 2 over 3. It would have been so much easier to just say 20 goes into here once and into here twice. Then maybe 15 goes into here once and into 45 3 times, and then we would have the 2 over the 3, because these are times. 1 times 2 is 2. 1 times 3 is 3. So it is much easier to just cancel out the 5s, to say that 3 goes into here once and into here 3 times. Be careful though, I think I will just do that with the numbers, and what I'll have upstairs is just the number 1, a, b to the 5th, and downstairs I'll have the number 3, a squared, b to the 2nd. Most people don't have much trouble with this because when you subtract those, you get b to the third, and that answer is upstairs, b to the third. You do have 1/3 here. A to the first over a to the second leaves you with an a downstairs. Yes, you could write it as an a to the -1 upstairs at first, but it's got to move downstairs. So I can write this answer as 1b cubed over 3a. I can just write it as b cubed over 3a because the 1 is understood. I could write it as 1/3, but this is kind of silly to separate this as two fractions. So we have simplified, and these particular problems don't involve much in the way of factoring. So same thing with number 3. So personally, I'm going to go ahead and say 8 goes into here once, into there 3 times. And then I'm going to say 5 goes into 5 once, and I think it goes into 125, 25 times. So numerically, what I'm left with in this problem is 3 times 25, or 75. I'm going to put the x to the 4th, the y to the 2nd, the z to the 2nd from the numerator all together. And then I'm going to put the y to the 5th and the z in the denominator. And I'm going to see then that I don't have to do anything with the x to the 4th. If you'd like, 2 minus 5 is a -3 for an exponent on that y. And then here, 2 minus 1 is z to the 1st, but you really need to put that y to the -3rd downstairs, and just that y to the -3rd downstairs, and call it y to the +3rd downstairs. Let's go ahead and do 2 more, maybe 2 or 3 more. Let's get through some of this multiplication, and then we'll switch to division. So if you can factor, you should factor things. So the t squared, you know, I can think of it as t times t, or I can just write it as t squared. This t squared minus 4 is the difference of squares. That factors into t plus 2 and t minus 2. Very nice. I'm sorry, this is a multiplication symbol. Downstairs, this fraction right here has a greatest common factor to take out. It's t times t minus 3. The reason I wrote this t squared over here as t times t is because I knew I was going to want to take out one of these with that one right there in a bit. The numerator is a trinomial with just a 1 in front of the squared term. So I'm looking for two numbers that multiply to be a +6. +6, but they have to add to be negative, so they better both be negative numbers. They probably have to be 3 times 2 to multiply to be a +6 and add to be a -5. Now, caution. The common factors need to be 1 on top and 1 on the bottom. It does not matter if 1 is way over here and way down here. That is 1 on the top and 1 on the bottom. And then here is 1 on the top and 1 on the bottom. What you have to be cautious of is if you lose everything in the numerator, then all you have left is a 1 upstairs. But I didn't lose everything. I still have a t upstairs. And downstairs, I still have a t plus 2. Don't try to cross off those t's. This is a monomial, and this is part of a binomial. They have to be exactly alike as binomials go, or you cannot reduce them. Okay, let's keep going. So just a few more. M squared minus n squared factors into m plus n times m minus n. That's the difference of squares. Downstairs, I can get a greatest common factor of 4 out of those, and when I do, I'll need an m plus n. The second fraction can't be factored, so m plus n it's like it's times 1, so put it in parentheses since it can't be factored, and m minus n downstairs. Now I'm going to cross off. I happen to notice this one first. There's an m minus n, 1 on top, 1 on the bottom. There's an m plus n, 1 on the top, 1 on the bottom. And finally, we're left in a simplified form. This answer would just be m plus n over that 4. This m plus n over that 4. This one has several steps. So up here in the numerator, I would take out a 2 first. And 2 goes into 98 49 times. So that problem's factored form is going to have the greatest common factor of 2, but then the t squared minus 49 is the difference of squares. So a t plus 7 and a t minus 7. Down here, I've got a 4 to take out before I factor that into the difference of squares. So I have a 4, but the t squared minus 1 factors into t plus 1 and t minus 1. Over here on the far right, there's a greatest common factor of an 8, and when I take that out, I need a t plus 1, 8 times the t plus 1. I'm willing to bet that the 16 goes into 112, and I'm looking to find this problem. It looks like it goes into 112 7 times. Oh, interesting, because, you know, look, there's a t minus 7 over here. So 16 times t is a 16t, and 16 times 7 is that minus 112. So let's go about crossing things off that are alike. So I just had that t minus 7, so I'm going to cross 1 on top, 1 on the bottom. Let's go with the t plus 1, 1 on the top, 1 on the bottom. I cannot cross these off. I could reduce these fractions right now. So I could say 2/4 is 1/2. And I could say 8 over 16 is 1/2. So I'm left with, in the numerator, all the numbers have disappeared besides 1. So I have 1 times t plus 7. You don't really need that 1. In the denominator, I have 2 times 2. 2, and then this times 2 is 4. And then I have the t minus 1. That's the neatest way to write this. I'm trying to think if there's another way. You could pull the 1/4 out in front. I'm going to stop here.